Welcome back. This is the second theorem we're proving. Remember, we have to know how to prove these theorems. Take your time to go through them. These are the theorems you have to know. One of them is going to be in the exams, right? But now I want to prove that the line drawn from the center of a circle that bisects a chord is perpendicular to the chord. That's what I want to prove. We're given a circle with center O, then PQ is the chord, and then we're given that PM is equal to MQ. This is given. We are required to prove that OM is perpendicular to PQ. Want to prove that this angle here is 90 degrees and also this angle is 90 degrees. Remember what I said. You have to remember the theorems that you have to use to prove this particular theorem, and also you have to remember the constructions. So the constructions will be the same as the ones we did in the previous theorem. So we're going to construct OP and OQ, creating triangle PMO and triangle QMO. Okay? And then now, the theorem we're going to use here, we're going to use congruency. We're going to use congruency to prove that this angle, let's name it M1 and M2, both of them are equal to, or each of them are equal to 90 degrees. Okay, right. So we're going to use congruency. So let's say in triangle PMO and triangle QMO. You see that I'm trying to also align the angles. Angle P going with angle Q, and then angle M1 going with angle M2, right? P with Q, and then M with M. That is M1 and M2. You can also say O1 and O2 here, right? O going with O there, right? And then we want to prove that angle M1 is equal to 90 degrees and angle M2 is equal to 90 degrees. So like we said, we're going to use congruency. So let's do that. So OP, OQ, they are radii. So we can say OP is equal to OQ, they are radii. Right? Okay. We are also given that PM is equal to MQ because we're told that they are what? They are equal. Right? So we can say PM is equal to MQ. Right? Given. Right? And then what else are we given? Remember the conditions for congruency. We have side, side, side. Okay? And then we have side, angle, side. And then we have angle, angle, side. And then we have right angle, hypotenuse, side. Remember this. So now we have proved that the two corresponding sides are equal. And then what can you say about OM? OM also is equal to OM because it's a common side. It's a common side. Right, now we have proven that the three pairs of corresponding sides are what? Are equal. So we can conclude and say, therefore, triangle PMO is congruent to triangle QMO. And then the reason side, side, side. From congruency, what can we say? From congruency, we can say that M1 is equal to M2. So we can say, therefore, angle M1 is equal to angle M2. And then what's the reason? Because triangle PMO is congruent to triangle QMO. Okay? But check angle M1 and M2. These are adjacent angles on a straight line. Okay? So we can say, but angle M1 plus angle M2 is equal to 180 degrees since these are adjacent angles on a straight line. But we said M1 is equal to M2. Okay, so it means we can replace this M2 with M1 and then say M1 plus M1, so it becomes 2M1 is equal to 180 degrees, right? Then divide by 2 on both sides of the equation. We found that angle M1 is equal to 90 degrees. You see that? and then angle M2 also is equal to 90 degrees because these are equal. So we've managed to prove that OM is perpendicular to PQ, since this angle is 90 degrees and then this angle is 90 degrees.